Question 2. Question 2 is about buffers. So I've got a acid dissociation constant, an equilibrium constant for an acid for ethanoic acid. So ethanoic acid is breaking up to make CH3CrO minus and H plus. And I've been given the expression for the acid dissociation constant Ka, the equilibrium constant for ethanoic acid. I've been given a value for it. A buffer solution with a pH of 3.87. So why have I been given 3.87? The reason I've been given 3.87, pH of 3.87, the only reason is because pH is minus log to the base 10 of hydrogen ion concentration. They want me to use the pH to work out H plus concentration. So that's the first thing that they want me to do. So if pH equals 3.87, so minus log to the base 10 of hydrogen ion concentration pH equals 3.87, then what I do is I minus both sides so that log H is minus 3.87, and then I can inverse log or shift log or second function log, find the right button on your calculator, of 3.87 to find the hydrogen ion concentration. It comes out as 1.3489 times 10 to the minus 4. So now I've got the hydrogen ion concentration. A buffer solution, in the buffer solution, the concentration of ethanoate ions, that's those on the top, was 0.136. I've got to work out the concentration of ethanoic acid on the bottom, so I've got all the values I need now. So I've got 1.74 times 10 to the minus 5 is the acid dissociation constant, equals 0.136, which is the concentration of ethanoate ions, which I'm given in the equation. Hydrogen ion concentration I've just worked out, divided by the concentration of ethanoic acid. So that's the concentration of ethanoic acid on the bottom. It should have square brackets around it, really. And so concentration of ethanoic acid is 0.136 times 1.3489 times 10 to the minus 4, which comes out as 1.83 times 10 to the minus 5, divided by 1.74 times 10 to the minus 5, and the concentration is 1.05 mole per decimeter cubed. I've put 3 significant figures because everything else in the question is to 3 significant figures. In a different buffer solution, the concentration of ethanoic acid was 0.25 mole dm to the minus 3, and the concentration of ethanoate ions was 0.121. Some sodium hydroxide was added to 500 centimeter cubed of this buffer solution. So I've got the volume of each of volume, and I've got the concentrations of ethanoic acid, and I've got the concentrations of ethanoate ions. So if I've been given concentrations and volumes, then I can work out the number of moles of ethanoic acid and ethanoate ions. So for ethanoic acid, concentration is moles divided by volume, so 0.0260 is the number of moles divided by 0.5, so I've turned 500 centimeter cubed by dividing it by 1000 into decimeter cubed, 0.5, and so I've worked out the number of moles of ethanoic acid is 0.13. I've done the same for sodium ethanoate, so concentration 0.121 is the number of moles divided by the volume, which is the same volume because it's the same solution, 500 centimeter cubed or 0.5. 0.121 times 0.5 is 0.0605. So I've got the number of moles of each of them in this buffer solution. I've added some sodium hydroxide, and it tells me that the amount of sodium hydroxide, it's given me the number of moles, 0.007 moles. Now what the sodium hydroxide does is it reacts with the acid. So the sodium hydroxide will react with the acid. So because this is an alkali or a base, sodium hydroxide will react with the acid. So instead of being 0.13 moles, some of the sodium hydroxide, 0.007 moles of this, have reacted with some of this. So the amount of ethanoic acid that I've got left is what I started with, 0.13, take away 0.007, because the sodium hydroxide is reacting. It reacts 1 mole of sodium hydroxide reacts with 1 mole of ethanoic acid, so 0.007 moles of sodium hydroxide will react with 0.007 moles of ethanoic acid. So 0.007 moles of ethanoic acid have been used up. So the amount remaining is what I started with, 0.13, take away 0.007 is 0.123. Now, when it reacts, what does it make? Well, it makes something called sodium ethanoate. It makes ethanoate ions. So, sodium ethanoate started off with 0.0605 moles of sodium ethanoate. When the sodium hydroxide reacts with the ethanoic acid, it makes sodium ethanoate. It makes more of these. So it actually adds on 0.007 moles of sodium ethanoate because 0.007 moles of sodium hydroxide react with 0.007 moles of the ethanoic acid to make 0.007 moles of sodium ethanoate, so we need to add that on. We add those two together and then we put in all of the numbers, we work out H plus and we work out pH, and pH will turn out to be 4.50 to 3 significant figures. I've put a 0 on there because everything else is to 3 significant figures.